In today's world, we can see the flow of information, especially digital information, has become critical ingredient for success in any activity. That is why the period we live in is often referred to as an information age. It is a simple fact that everything human beings do, they take place at a certain location on the earth. It has a geographic component. The digital information revolution of the late 20th century has allowed this spatial information to be more easily accessed. It can be said analyzed and used than can ever before. So this has led to the development of SIS as a spatial information science, I mean SIS when I will say, as a discipline and emergence of GIS as a course of digital technology. If we see traditionally, the discipline of geography dealt with spatial description and analysis, but now in the area of multidisciplinary approach we are living in, the students, researchers, decision makers, professionals from the different disciplines can find their way into emerging discipline of GIS, making it popular. The rapid expansion and popularization of GIS means that now spatial science is not just for specialists, but it can be said for everyone, but these users have different requirements. So this course will attempt to provide all the basic fundamentals of space-oriented training, mainly for the students and the professionals. As you're asking regarding the benefits of this course, as this course refers to the spatial information science, here we are dealing with all the spatial components, mainly in the GIS environment. So we have already introduced this course as a multidisciplinary, but we have a lot of things in different disciplines like engineering, whether we deal with the geography, whether we deal with the even with the we can say health sector or even with the planning sector. Everywhere we need such spatial information. So how you are going to many times the spatial information is just regarded as mapping of certain components. It does not seem to mapping of the certain components. We we use to locate the things or the we can say the features spatially. So according to the need we can plan it. For example, if we want to have the to develop the health sector, for example, any new health sector has to be located somewhere. So we have first we are going to have the spatial information regarding the particular unit, that where are already the health sectors are already existing, and how much population is there in different units, and accordingly where is the need of this sector. So we will get this spatial information, and accordingly we are going to map it and get the best location that where is it should be located. Not only this, even we can have many times we can also map the futuristic things on the basis of what the past spatial information we are having or the present information we are having. So according to that, even we can map the futuristic thing for the planning purpose. So that's why this is a multidisciplinary thing, we can say spatial information science, that is needed in various different sectors. If you'll ask more, I can say that it is a very simple fact that everything the human beings do or take place at a certain location on the earth, it has a spatial component. And when we get this digital information of nowadays, which was not very much available in different things. Yes, exam pattern already you have done assignment. The examination will pattern will be almost similar to this, but it will have more questions, and the questions will be in the form of MSQ, MCQ, and one word. That's it. No essay type question, small answer question will be there. Due to some technical glitch, the meeting ended. So there was a question regarding the that examination pattern. So examination pattern will be similar to the assignment pattern, just the question numbers will be more, and that will have MCQ question, MSQ questions, and one word question. So that you have to see. And there was a question from somebody regarding whether we have some remote sensing applications for the we can say Mars, Moon, and all. So yes, remote sensing techniques are extensively, I can say, applied to study the heavenly bodies. like Moon or Mars, we can say, or we can say even the planetary bodies. It allows for the collection of data mainly for the physical and chemical properties of the celestial objects, mainly in direct contact with it. So it helps in the lunar explorations, I can say. It also helps in topographic mapping. Also help in the mineral composition, I can say. So these are the few of the things. So when we will go more in depth, then we can explore more here. But yes, there are the techniques available in the remote sensing where we can have I can say we can have a remote where the remote sensing really allows the collection of data about the celestial objects. Um, Question regarding that someone has asked regarding those applications where we can download the TIFF files for the Mars and Moon. Actually, this course is very much related with the spatial information science. Here we are dealing with the more of the features on the on the Earth surface. So, but still, if you want to know about whether we can download these uh, TIFF files for the Mars and Moon. I can tell you a bit here, but more information you can retrieve, or you can ask me on my personal chat, or you can ask me on my personal email ID. Email ID. So mainly this course is related with the Earth feature mapping and spatial information science as it deals with. But still, I will allow that you can ask these queries on my personal email ID. But still, if you wanted to know, I can tell you here a bit that mainly there is a NASA's planetary data system which can help you for this. You can explore NASA's planetary data system that is known as PDS for moon data, especially you can also, I can give you on chat the website where you can explore this data. Just wait, I'm giving here. So I'm going to end this meeting. If you further have any query, you can either ask me on mail or you can ask for, I can take another live session. Thank you.